So today we're here to welcome Damon High from High Speed Rail Solutions. He's joining us from England. So he's right now after his work day, he's taking time to speak with us about safety at work, which is one of our pillars, as you all know, as members and guests of the TRACCS webinar series. Today we'll discuss engineering safety management and complying with the CM-REA for railway systems and what it means to all of us, right? So I want to thank you, Damon, for being here. And I wanted to introduce you properly. Damon has had 17 years of experience in the UK and European and Middle East rail systems. And he's got vast experience in engineering assurance markets. He has vast knowledge of systems and technical assurance and engineering safety management, and has developed a number of safety cases and engineering assurance artifacts, both from the side of the client and the developers. His knowledge of the requirements for all the parties to ensure that the projects are properly supported is going to be a treat to all of us. So we really appreciate you being here. Welcome, Damon. How are you?
Yeah, I'm good, thank you. Yeah, thanks for having me, Andrew. And yeah, thanks for everyone joining today. Really appreciate it. Obviously, different time zones for some of you. Some people I recognise on the list there. So better get this right, Andrew, because I know what they're talking about too, some of these guys on the list. So
perfect. So before we start, Damon, I want to ask people, if you do have questions while Damon's doing his presentation, you may very well type them in the box. And if it's something that we can address at the moment, we will. And if not, there will be time for questions at the end. So Damon, we are all ears.
Brilliant. Right. Thank you very much. Right. Bear with me, guys, while I try and do the first technical bit, which is to move things around and find the right screen to share. So bear with me. Let's try and not fail at the first hurdle. Okay. So in theory, you should see a presentation in present mode. Is that? Yep. Awesome. Yes. We've got some thumbs up. Love that. Yeah. Okay, brilliant. Yeah, so hi everyone. As Andrew says, I'm Damon. I'm Managing Director of High Speed Rail Solutions. Appreciate you joining today. Hope you're all in good health. As Andrew says, we're going to be looking at the Canadian method for risk evaluation and assessment for railway systems, and how that will impact you and your roles in the rail industry. So as part of this webinar, I'll try and provide some useful insight into the requirements of the CM-REA, and apologies if I sometimes slip out with CSM. That's what we're used to working with from a European equivalent perspective, and I'll try and throw in some of those hints and tips as well as to how that's been deployed on projects and how that would apply to projects in Canada. We've got lots to get through, trying to condense it down to about 45 minutes or so from a much larger presentation. So we'll get to it, and hopefully I can answer some questions at the end for you as well. Okay, so I think that's progress, which is good. So in summary today, we'll be giving you a little bit of background to the CM-REA. We'll go through some of the key terms, the actual risk management process, so the meat of it, as it were, and also some of the key aspects of it. So looking at significance assessments, hazard identification, working with independent safety assessors, and I believe there's a previous gentleman I used to work with that's on the call that would fit that category. We'll break it down into some life cycle activities, what it means to you and your role, and as I say, hopefully we'll have some time for questions at the end. This is the first edition of the CM-REA. So this is CSA R114. So it was issued in October 2022 by the National Standards of Canada. So it's National Standard of Canada issued by the CSA. So it was adopted from the European equivalent, which is called the Common Safety Method for Risk Evaluation and Assessment. And it's also taken into account some other European directives with respect to the interoperability of the railway system within the EU and also the European Safety Directive. Previous to the formal issue of this standard in October this year, back in October 2020, there was a draft paper, CSA EXP11, that was produced with the origins coming from Metrolinx and other organisations being a bit concerned about how system safety within their portfolio of projects was being considered. So I think they went to look at how it was being implemented on railways further afield, and that's where a lot of the adoption from CSM came about from the European perspective. Now, just a bit of confirmation in terms of the types of safety items that we're going to be talking about today, and that's going to be essentially system safety as opposed to construction safety. So the CM-REA addresses the safety of the system once it's in operational service and it's being maintained as business as usual. So therefore, we're considering the railway system when it's in its final configuration, and therefore once all construction type activities have been completed. So the construction safety addresses the safety and change in the configuration of the railway, as opposed to necessarily its final configuration. But there can obviously, as with all things, there can obviously be quite a bit of an overlap sometimes, especially when we have lots of complex stage works on railway projects. So we're looking at this from once that railway system is in its final configuration. So in terms of why we do what we do, so essentially we're looking to prevent accidents from occurring. We're trying to prevent people, anyone that interacts with the railway, preventing them from coming to harm. Some examples of some of the operational maintenance type accidents that have occurred. So those that we are interested in from a CM-REA perspective, we've got some screenshots on this slide that have been taken from accidents that have occurred in the UK. And some of those causes of rail accidents have been switches and crossing failures. We've had wrong side failures caused by maintenance activities, signals passed at danger, and also where we've had incidents at level crossings and road vehicle incursions. So the last one on that list there, we've got a little bit more detail about that, to go into a little bit more detail into one of these types of accidents from a Canadian method perspective. So again, this is an example, unfortunately, an accident that occurred in Scotland a couple of years back now, and that was a derailment of a passenger train near Carmont. So in terms of the actual conditions on the day of the accident, it was quite heavy rain. I don't believe anything too out of the ordinary for what you can get up in Scotland, for example. But unfortunately, this train, during various manoeuvres, struck debris that had been washed out of a drainage trench and subsequently derailed. And through investigation, that drainage system, it was found, and the associated earthworks hadn't actually been constructed in accordance with the original design. And actually, they found that how it's been constructed, it wasn't able to safely accommodate water flows that were occurring that morning. And again, through the investigation, they realised that there was no as-built drawings and a health and safety file that had been produced at the back end of the project that is then normally handed over to maintenance teams. So they have all the right information to make sure that they're adequately maintaining these assets. So that's just a few examples of some of the things that we're obviously looking to try and prevent through these risk management activities that we go through. In terms of some of the key terms, I've just picked out some of these from the standard. Obviously, there's a lot more there, but some of these terms I'll be using as we go through the presentation today. So an independent safety assessor, so they will be normally it's a third-party organisation that will undertake essentially that independent assessment of the safety activities that have been conducted on a project. They're normally involved early in the project and see it all the way through to the end, and they'll be involved in assessing a lot of the key documentation that you produce as part of following this standard, and making sure that it's demonstrating that safety has been controlled to acceptable levels through the project. And they produce various deliverables as well, confirming their support or not as the project progresses. An infrastructure manager is an entity responsible for maintaining the infrastructure. So, for example, Network Rail in the UK is the infrastructure manager organisation. When we use the term proponent, so that can mean any one of those following definitions on the screen there. So, a railway entity, an infrastructure manager, entity charged with maintenance, or another applicant that is seeking an authorisation to place their system into service. So, for example, a Metrolinx would be covered as a proponent, so essentially the end client, as it were, and also the phrase participant. So sometimes I might say suppliers or something like that during the presentation, but participants is defined in the standard as all parties that are directly or through contractual arrangements involved in the application of the standard. And so the proponent and the participants all have a duty to make sure that they're involved in the identification and management of hazards through the risk management process. So that risk management process, don't worry, don't expect you to be able to read all of that. We'll break it down into stages in a moment. Essentially, if we start at the beginning, it's essentially defining your engineering change, normally covered by the system definition document, but we can look at other terminology in a moment. Hazard identification activities, risk acceptance principles and evaluation, generation of safety requirements and how we demonstrate compliance to those requirements, and also the involvement of independent safety assessors and hazard management activities as we go all the way through the process. Now, I've already mentioned independent safety assessors a couple of times, and normally that's determined whether or not one needs to be brought on board through a significance assessment. And as per the standard, so that what we have on the left-hand side is an extract from the standard. So if the change is considered significant, then the risk management process as defined in the standard needs to be followed, and that means that you'll also bring on an independent safety assessor. But if the change is considered not significant, then essentially you need to keep adequate documentation to justify that decision, and also therefore you'll be following a more slimline version of the risk management process, and you won't need to involve an independent safety assessor. So in terms of the criteria that we need to look at to determine that significance, that's generally on the right-hand side. So we need to look at determining what the failure consequence of the project may be. So what's the credible worst case scenario in the event of failure of the system? So is it things like a slip, and a fall, or is it actually something that could lead to collision between trains? Novelty used in implementing the change. So are we using, say, a brand new signalling system that hasn't been used before on the network? Complexity of the change, so how many parties are involved? Is it multidisciplinary? Whether or not anything can be monitored during the implementation of that change through the life cycle, and can we intervene appropriately as we may need to? Reversibility covers whether or not we can revert the system back to its previous state. So if something's not going well, can we reverse it back to where it was before, where we felt safety was okay? And from an additionality perspective, assessment of the significance of the change, taking into account all recent safety-related changes to the system under assessment that were not judged to be significant. So we're making sure that we're not breaking things down into more manageable chunks and hoping that the overall piece wouldn't be considered significant. So there's different ways that people generally go about trying to understand that significance decision. Normally, a core group of people will make that decision. It won't necessarily just rest with one person. And in the UK, it's been done through various means. We've got like a risk matrix, as it were, that's on the screen that's been used once you fill in various cells on an Excel spreadsheet, and that helps you come up with an answer. And things are now moving more onto following a flow chart of specific questions to, again, help you determine that significance. And as I say, whether or not you need to bring an independent safety assessor on board. Okay. So defining the engineering change. So this is just in the system definition document. And there's a number of criteria that need to be met by this particular document. So it's important to make sure that we don't just talk about the changes that we're going to make as part of our projects and the engineering change that we're making, but also the current configuration of the railway, so people get a good feel for where we are today and what the end state, that final configuration, will look like once the projects are finished. So we need to describe the objective of the system and what its intended purposes. So that may be, for example, provision of 25 kV overhead line electrification for a new fleet of electric trains. What's the functions of the system and each of the subsystems that make this up. So even, for example, on a pure overhead line electrification projects, that's going to impact other subsystems as well. We'd also need to consider this from a maintenance and operations perspective. We've got a little bit more slides in a bit regarding system boundary, physical, functional interfaces. What's the environment of the system being included or altered? So we need to look at the climatic conditions, potential shock and vibration, and also things like what the electromagnetic environment is like as well, and what are our neighbours and what impact can we have on the neighbours to the railway system. When it comes to looking at existing safety measures that might already be in place, so we might have fencing in place along the railway to prevent trespass. We may already have a seal 4 signalling system in place, warning signage and other items like that. And it may be that some of those existing safety measures may need to be altered or changed completely as a result of the project that we're looking at. Safety requirements within the system definition. So normally they do go in there, but normally that's right at the end of the projects. Generally for live management of safety requirements, normally I've sort of personally found that could be best done in the hazard record or the hazard log as the project progresses, so that it's easier to log new entries in a live document like the hazard record, as opposed to regularly updating the system definition. System definition does need to be updated as we go through the process, but if you're doing that every time a new safety requirement is generated, then that might be a little bit more frequent. And finally, assumptions that need to be considered as well. So we might have some assumptions that the pre-installed fencing might be compliant to current requirements or requirements to meet the new system being in place. So it's just a case that we would need to make sure that any of those assumptions that could have an impact on safety validated as we go through the process. Okay, I think that changed. Okay, so I quite like the phrase "a picture paints 1,000 words," and generally when it comes to the system definition document, I definitely think that pictures definitely help with giving the reader the ISA an understanding of where and how some of the changes are being made. And that can come in various formats. Quite a few different examples on the screen there that we try and deploy where possible. System context diagrams help break down the system and its interfaces and its technical interactions with each other. Location maps and track diagrams also help give you a feel for some of the other assets that might be in the vicinity of your projects, that again you therefore might need to consider as part of your hazard management activities. And also system architecture descriptions as well can also help obviously make sure that those technical interfaces and functional interfaces are adequately addressed, and that we don't potentially let anything fall through the gap. So I mentioned a couple of slides back that the system definition is a live document, and this just give you a bit of an idea as to why. So this is reflecting the Great Western Electrification project in the UK that I was fortunate enough to work on, and what this diagram shows here is essentially the line of route of where the electrification was going to cover. The blue lines represent the route sections, so i.e. how Great Western Electrification was broken down into smaller individual projects. But as we were going through the process, what became apparent was the need to keep the document up to date for some more minor reasons, but some fairly significant ones. So as the project progressed, it was decided that the electrification project would not continue up to Oxford, and the route down here to Bath Spa and sorry, you probably can't see my cursor, from Bath Spa on the left to Bristol Temple Meads also wouldn't be finally built and commissioned. It's important to consider the final testing and commissioning activities as well as we go through the process. So as I say, the blue lines indicated route sections that would be brought into service. But then when we looked at the energization events, so how each of the areas would be energized and essentially turned on to allow for trains to run in an incremental manner, we found that those energization events didn't align with the actual route sections. So we got lucky over here with the first part of the project as we were moving from east to west, but then things started to not become aligned. So we had to make sure that as we wanted to energize the system, that we were leaving no gaps anywhere in terms of the safety argument and work that we were doing. So it's very important that we make sure that we keep the system definition up to date as we go. You may find, for example, that on some projects, like we did on this particular one, that it worked really well where we had an overarching system definition which gave all of the generic items and background about the whole project, and then we had individual annexes for each of the route sections or energization events, so that we could cover off specifics about systems and interfaces that needed to be covered in those particular areas. So sometimes it can be okay also to split a system definition up and include annexes for certain areas. So next up in the process is the hazard identification phase. So there's lots of different techniques available in helping to identify these foreseeable hazards and their causes for the projects and systems. The most common is that of hazard identification workshops. So where we look to bring all of the relevant technical, operational, and maintenance knowledge from different contracted organisations together to analyse the specific application in detail. And these hazard workshops are common at both proponent and participant level, so supplier level. Other techniques that might be used as well, depending on the type of project that we're looking to bring in, might be other analysis like fault tree analysis, interface hazard analysis, and failure modes, effects, and criticality analysis. And these are probably more relevant for when we're looking to introduce new products and systems onto the railway infrastructure for the first time. So normally the proponent would also be normally considered to be the systems integrator. So they'd be responsible for bringing all of the pieces of the puzzle together from all the different organisations. And as I say, participants would likely need to not only run their own workshops for their own particular systems in question, but also be invited to and attend any other workshops that might be arranged by the proponent to cover their scope of works. So I won't go into too much detail with this, but in terms of preliminary and system hazard analysis, what I find as well is that before everyone starts diving into hazard workshops and big groups of people together, generally through some desktop type studies that are conducted by looking at past projects of a similar nature, safety databases, hazard checklists that are publicly available, then it can already be then you can already build up a good picture of the types of hazardous events and their precursors that you'd be looking to have to deal with essentially as the project progresses. So you'd already have a bit of a talking point when you go into your first workshops, and you won't be starting these with a blank piece of paper, because a lot of the time the work that we do isn't necessarily new and novel, and we have covered this somewhere else through railway projects. And then as we move into the system hazard analysis, then that's where we might start to focus on some of the more detailed analysis as the designs become more detailed as well. And if we've identified any core hazards in those workshops, what we might need to cover off in more detail as we go through the process. So aside from the more traditional safety assurance type activities that we'd need to consider, we'd also have to make sure that the safety teams and safety engineers are also involved in reviews of other documents as well. I've got a list on the screen there as well. So terminology that I'm quite used to in the UK, so some of that might not quite neatly align with what we have in Canada, but for example, designers' risk assessments and decision logs may well contain CM-REA related hazards and not just construction ones. So we need to make sure that that they may have to be covered as well within our hazard record as well, so that we can make sure that they're managed all the way through the life cycle, and they don't just get raised in a design document, which then might not be picked up again later on. There might be change requests that are deferred, so that's quite regular with software and data intensive systems, but also for safety critical systems that are introduced, like signalling systems. Generally, that they come with their own generic application safety cases, and they may well have a number of safety related application conditions that, again, we would need to consider as a specific application project and demonstrate compliance to those as well. So there's lots of various artifacts that would need to be considered that could contain hazards that may need to be included within our hazard record. So the purpose of that hazard record is essentially to formally record all of the system safety hazardous events and their precursors. So it captures the description of the hazardous events, their precursors, the safety requirements to be implemented to mitigate against them, and also the compliance justification statements and links to relevant evidence throughout the life cycle that demonstrate that that hazardous event is controlled to an acceptable level. Now, the hazard record is arguably the most important document in the process, but it can also be the most troublesome, because they can get quite large and bulky. But I think with good discipline and regular reviews of the hazard record and dedicated hazard record managers, then I think a lot of these potential issues can be mitigated against. So as I say, formatting can be quite sporadic, which makes it difficult to navigate. So by the time you've read an entry from the left, and you get all the way to the right and the end, are we still talking about the same thing? I've seen that happen quite a lot. Revision history can be quite often severely lacking in detail, which makes it difficult to understand from a traceability purpose who is involved in the reviews who is involved in the identification of the hazards, and also who is involved in helping to demonstrate that any risks have been mitigated. Entries can get added in there without any control. Can't think of a better way of putting that, essentially. But if new entries are added blindly in there, it may be that we're not happy with the phrasing, or it may end up that we start duplicating hazards as well. And what we can also find is that when we get to demonstrating evidence that we're mitigating hazards, again, sometimes we might only be referring document numbers, but we're not actually given a proper compliance justification statement and signposting ourselves and the independent assessors to exactly where the evidence is to meet the safety requirements. So with all the hazards captured in the hazard record, we need to choose which risk acceptance principle we will use to mitigate it. So there's three choices: application of codes of practice, which is generally applying a standard, whether or not it be a potentially an international standard or a company specific standard. A comparison to a similar reference system, so where we've done something pretty much exactly the same before elsewhere, and we try and demonstrate that comparison. That bit isn't as easy as it sounds. And then explicit risk estimation. Now, this for me is where essentially it's not covered by either of the above, and maybe again where we're introducing a new system that we've not seen on the rail network before, and we don't have standards that we can easily demonstrate how we're going to mitigate those risks. But what we need to make sure that we do as well, and you know, this is still something that you know, I need to keep checking myself on sometimes as well, right? But sometimes we don't want to just blindly say that a potential hazardous event is going to be mitigated by application of a code of practice without really understanding if that hazard could be eliminated in the first place. So, for example, if we have a level crossing, a grade crossing, actually, could steps be made to actually close that crossing and therefore mitigate that risk of people or vehicles being impacted by trains over that crossing. So lots of standards to deal with level crossings, grade crossings, but actually, can we eliminate the hazard as part of our project works by closing it down? And sometimes, you know, as I say, sometimes it's things like that I need to check myself on as well as we go through. So generation of safety requirements. So these will be necessary to control the risks that we've identified from actually occurring, and very much like standard requirements management. A safety requirement must have a number of attributes, so it must be needed. So there'd be a safety consequence if it wasn't included. Is there a criteria for acceptance? So how can we demonstrate that we've met that safety requirement all the way through the life cycle? Therefore, it being technically feasible, and we must make sure it's clear, concise, and unambiguous. Generally, if we're using a risk acceptance principle, which is referring to a code of practice, then that safety requirement should also make reference to what that code of practice, what that standard is, but also that particular clause within that standard that we need to demonstrate compliance against as well, to help from a traceability perspective. If there's lots of very generic type safety requirements, then again, if independent safety assessors are involved, it makes it much harder to demonstrate how we're specifically mitigating that hazard, and therefore the evidence that we get at the end is sufficient enough. I think I've covered some of that in this one actually. But again, what we find is to help with providing that evidence all the way through the life cycle, as opposed to right at the very end, because again, you'll be independently scrutinised all the way through the process, not just right at the end. If things are done right, then we often find that it's also quite good to write down as we go through the life cycle what we would expect to see as evidence in the next phase. So we're asking the engineers the right questions, and we're making sure that we're finding the right pieces of evidence as we go through that process. So I'll touch a little bit upon residual risk and hazard transfer. So if we've looked at these hazards and they can't actually be eliminated throughout the design process, then there is a likelihood that residual risks may actually be present once the construction work stops and once that system is commissioned and in revenue service. So those residual risks might need to be transferred and accepted by other appropriate stakeholders. So that might be operators or maintenance teams. Depending on the contractual setup, it may well be that participants in the process, if say, for example, they're only involved in the design stage, they may have certain hazards that they will transfer over to the proponent for ongoing management when the designer leaves that particular project, so that we don't essentially forget about them and we can continue to manage them through the process after those design activities have been complete. And generally, so what we found to work very well with that is to again engage with these external stakeholders that might have to deal with some of that residual risk. Typically that escapes me for the moment, but it might be something like regular devegetation along the network to make sure that the vegetation doesn't encroach onto the overhead line equipment and flashovers, for example. So it's good to involve the people that would have to manage those residual risks as early as possible, bring them on that journey with you, so then when they come to formally accepting those transferred hazards, it just makes that process a lot more smooth. There we go. So amongst other things, specific application safety cases, safety justification reports, they demonstrate that each project, that the relevant hazards and their causes have been identified for the specific project. We've identified the correct risk acceptance principles, safety requirements, and that those safety requirements have been correctly implemented in the design and validated through construction, through as-builts. And that the residual risks have been transferred to and accepted by appropriate actors. So generally, I mentioned earlier that the hazard record is one of the key deliverables in the process. Generally, that forms a very big spreadsheet, and it can be very hard without supporting safety case or safety justification report to actually talk not only your independent peers within your own organisations, but also those independent ICEs. It makes it very difficult to be able to tell the story as to the work that you've done to make sure that you've identified all your hazards and you've controlled them to acceptable levels. So often a safety case or safety justification report backing up those hazard logs, those hazard records, are valuable as well. And normally they're to get produced at various stages of the process as well. So normally it might be during option selection. It might be when you get to detailed design, so you can demonstrate that your detailed design has met all of the safety requirements. all the way up through to commissioning. But again, as you guys all appreciate, sometimes you can't completely close a hazard until you actually get to that night of commissioning, because you don't get that final piece of evidence until your tester in charge has signed off his test certificates and all that good stuff. So therefore, when you come to pre-commissioning, just before commissioning, you're not going to have everything closed. So post-commissioning, so when the works have been done, you'll then need to do an update to your safety case just to show how any of those residual items in there have been closed out. Okay. So declaration by the proponent. So the proponent needs to produce a written declaration confirming that all of their identifiers, hazards and associated risks have been controlled to an acceptable level. So in the UK, this has been called a Declaration of Control of Risks, so DOCOR. So I'll be honest, I'm not aware of what that will be called. On Canadian projects. So normally, it's signed by the sponsor, engineering, and program management leads, and sometimes it may well be that you have your declaration of control of risk, your certificate, as it were, might be backed up by a letter supporting the contents of that DOCOR, where any sort of non-compliances or recommendations contained by the ISA have been demonstrated. So just a few short words about working with independent safety assessors if your project is deemed significant. So firstly, I guess don't freak out. So they want your projects to succeed, and you know, even more than that, a large number of them are very pragmatic in their approach. As I mentioned about some other stakeholders earlier, start engaging with them early, but also make sure that their remit is clear and that everyone's on the same page as to the depth that the ISAs will be going into. The project should essentially provide the remit, and in response, the ISA will provide their independent assessment plan. So you need to also make sure that your project team are familiar with it. It will include dates for when certain deliverables are expected, based off of when you're submitting evidence to them. And during the actual process, the ISA on key bits of deliverables will provide deliverables such as assessment records or observation sheets on key documents to help you address any concerns that they may have early before you get to that final submission of your safety case. The final document produced by an ISA is a safety assessment report, otherwise known as a SAR, and that SAR will either be supportive or not of the application of the process and demonstration of how you've safely integrated your project into the railway network. Oh, apologies for that, skipped on a couple there. Yeah, right, back on track. So not too much to show on this, but sometimes the Canadian method, very much like CSM, it's very much a linear process, and it's sometimes hard to understand how that fits within a life cycle of a project. What I've got on the screen here, many of you will be familiar with, just a pure extract from CENELEC standards, so 50126 and the V life cycle. And the reason why I just wanted to bring this up on the page is just because 50126 was updated to align with some more of the terminology within the Common Safety Method regulations a few years back, and a lot of the procurement specifications that are being raised in Canada now that talk about the Canadian method are also referring out to CENELEC standards as well. And as you can see through some of the wording on during the V life cycle, we're talking about system definitions, risk analysis and evaluation, specification of requirements, so not just technical requirements, but the safety requirements that we've identified through the process. And and again, as you can see, this is starting early in the life cycle. So we're not waiting until we're in design or constructions to start this process. Now, I know that sounds obvious, but sometimes we still get called into projects quite late where either things might not have been done or people have tried but just not necessarily had the right understanding as to how the process works. And then I've got, again, this is purely just an extract from 5126, not going to take any credit for this. But again, just wanted to sort of show you mainly on the right hand side, in the right hand column, again, some of the activities that are called for during each stage of the life cycle. So again, it's very much similar to some of the items and deliverables that we've talked about during the process. So safety plan to map out your activities and the safety analysis you'll do. The fact that you need to establish a hazard log, engage with the ISA to have an independent safety assessment plan, and also as we go through that process, and I'll skip on onto the next couple of slides quite quickly. But again, just making sure that we update these deliverables as we go through the process. So there we go. Very quickly, just to talk about this from what this looks like from a timeline perspective sometimes. So I don't expect you to necessarily be able to read it, but this is an example of a program that's got multiple projects in it, where they have different commissioning stages, different design stage gates. But again, all of this, the whole process needs to be considered prior to those commissioning and key gates, because these are the ISAs will require certain periods of review time that they're writing their ISA plan. It might be 8 weeks, 10 weeks, 12 weeks. So you need to build that into your process to make sure that have adequate time and you're not giving everything to them right at the very end of the process. Because the more engaged you are, the more that you submit documents on time to them, then the more controlled that they will see that the safety is being managed on your particular project. So in terms of what it means to particular disciplines, so if we look at everyone that's generally involved in the project, what do all of us need to be doing? So firstly, we need to be participating in demonstrating that hazards and their causes have been identified. As I say, more often than not, this will be through attendance at workshops. We need to get involved in generating safety requirements, because the discipline experts, the discipline engineers will know their systems better than the safety engineers that come in to help out on projects. But also they'll need to be involved in the generation of risk assessments and provision of general assurance evidence that we can use in our hazard logs. So generally that's everything that everyone will need to be involved in. Sponsors and project managers, so they'll need to make sure that staff are aware of their responsibilities with respect to system safety. They need to help by making sure that there's sufficient budget and allowance made in the programs to allow for these activities to be undertaken without pressure. As we mentioned, a lot of these deliverables have to be submitted quite a number of weeks out prior to commissionings, and lots of different parties have to be involved before the thumbs up is given for that project to be commissioned. So that time needs to be built into the program. They'll need to help produce the preliminary system definition, conduct the significance test, because it's done very early in the process, and help making sure that each of the participants, each of the suppliers, are aware of their requirements in terms of meeting the requirements of CM-REA. It's not clicking. There we are. So the project's engineering community. So again, I've tried to make this quite general. Hopefully it gives a bit of a flavour. As I say, there might be a number of risk assessments that are conducted as a general everyday type activity on projects. So signalling engineers may regularly conduct signalling overrun risk assessments, all of which will feed into the hazard record activities. So again, being those discipline experts, they'll need to help work with the safety assurance team to help make sure that we're compliant to the right that the right standards have been identified, and that we're also producing the right set of evidence to help make sure that those hazards have been mitigated against. Design teams will have to help demonstrate how safety has influenced design. So how those hazards have been controlled at design stage, what work's been done to try and eliminate those hazards, what hazards have been eliminated through those design type activities. They'll need to produce some design evidence to show how safety requirements have been met. So this might be electrical clearance drawings, so cross sections to show that we've got the right distances between where people could stand and the closest live part of an electrification system, so that we can show that we're meeting the right clearance dimensions. And as I said earlier, for those designers that might not be involved in the actual construction side of activities as well, it may be that some of those residual risks has to be transferred over to the proponent for ongoing management as well. Construction organisations obviously have a role to play as well, not just in managing their construction health and safety type activities, but also in the system safety activities. So, for example, it might not be possible to build some railway infrastructure strictly in accordance with the design. So we mentioned Carmont earlier as an example, but then they would have a duty of care to make sure that non-compliance with that design is raised and help identify any residual risks that might be associated between that delta, between that design and that as-built scenario. And we've had instances where, for example, a design has meant that a safety requirement has not been met, and then further work has had to be done through risk assessment to try and help understand how that's not going to impact the safety profile of the system. So they've very much got a part to play in the process. Operational readiness, so operations personnel will need to make sure that their operational documentation has been updated to reflect the new system. So that might be isolation diagrams, operations instructions. Drivers, for example, might need to be briefed. Ops staff might need to be trained on new signalling systems, for example. And because they all work with their own safety management systems as well, then the project will need to provide packs of information to them to help make sure that these operating companies and freight operating companies can assure their peers that they are also ready for this system to be brought online. And as I say, they may have some residual risks that they need to accept through the process. From a maintenance perspective, again, do we need to do any additional training? Have we got adequate access for them once the new railway infrastructure has been built? Have maintenance manuals been updated? And again, are they aware and have they accepted any residual risks that might be introduced by the project? Right, so apologies, I've gone on a little bit longer than I'd intended, so appreciate your patience, but that's essentially it from me. We've covered the background to the Canadian method, key terms, the risk management process. We've looked at significance assessments and how different ways are done for that. A number of ways for hazard identification, a few tips with working with ICEs, and we've tried to bring some of that into the context of what that looks like from a life cycle perspective. So yeah, thank you very much for that. Appreciate you sticking with me.
Damon, first of all, thank you so much. You asked me a question earlier, and I think that it would be fair for everybody here to answer it to the best of their ability. So I'm going to launch a poll right now. The poll is asking everyone here what you think. Do you think the rail industry in Canada is ready for this standard? So you are able to vote. You will have a notification to the bottom right corner there. And number 1 would be not ready at all. And number 10 would be perfectly ready. So we're looking forward to hearing your answers as members and members of this industry. So please go ahead and vote. If you are not able to cast your vote in the poll for some technical reason, you're welcome to put your answer in the chat as well. I think this is quite interesting. I see that some people need to drop off to attend other calls, but I'm sure if there are any questions, everybody will be happy to contact us. Damon, if you want to put your contact information on the screen for people to copy that, that would be great as well.
I'll share that again. No worries.
Yes, please. So we have for now, overall votes are not, but we're not very confident in our readiness for this standard.
Okay.
So Mark is sending a message to everybody reminding that the recording will be posted for our members to revisit the issue. And of course, Damon can answer specific questions that you may have. You can contact us as well. High Speed Rail Solutions is a member of TRACCS, of course. So yeah, I see that people are in between 2 and 7, not very confident about our readiness. So definitely important to think about these things, to continue having these conversations. So really, thank you very much. Does anybody have a specific question that you would like to ask Damon right now? So I have here a question from someone who emailed us.
Okay.
Let me see. So the question is, our company is involved in design activities only. What role do we play in terms of compliance? And who manages the engagement with the independent safety assessor?
Okay.
Yeah.
Yeah, no, that's cool. Yeah, so from a design perspective, yeah, so it's never too straightforward, really. I suppose some of it depends on how it's broken up from a contract perspective. Sometimes the proponent tries to pass everything down onto participants, but the proponent is still accountable and needs to be involved and take accountability for the process. But generally, the design organisations will need to be involved in hazard identification activities. They'll produce designers' risk logs, generally, which shows any sort of risks that have been raised and how they've managed that through the design process to help make sure that that can be fed into the overarching proponent hazard record, so that then can be managed through the process. So generally, they might also, they will have to also provide a number of bits of evidence as well to help demonstrate how their design has met the safety requirements that have been identified. So I've used electrification as an example a couple of times. So they'd have to provide designs which show that they've got the right clearances in place, that adequate earthing and bonding has been included in the design, and items like that, really. And sorry, Andrew, what was the bit about the ISA at the end of that bit?
So who manages the engagement with the independent safety assessor?
Okay, cool. So yeah, thank you. So normally, again, that's done at by the proponent at the overarching system of system level. So normally, proponent will manage that interaction with the ISA. However, it may well be that suppliers of safety critical equipment, i.e. new signaling systems, also may have their own internal independent safety assessors that they need to engage with. So it might not, so it may be that the signaling supplier has to satisfy their own internal ISA before then that information and their safety case is submitted to the proponent for review by the proponent ISA. So the sort of system of system overarching ISA.
Okay, so not a straightforward situation. Thank you for clarifying that. I see here people, some had to leave, but they're thanking you. And we from TRACCS, we are thanking you for such an a detailed analysis and the overview of everything to consider. It's definitely important, and this is new. As you said, this came out October 2022, which is last month.
Yeah.
So we want to thank you, and we want to thank everybody who participated. We will see you soon. Stay tuned on social media and our newsletters for more news about what programs we are developing and what events are coming up.
Yeah, perfect. And if anyone does have questions that they email us afterwards, Andrew, I'll make sure I'll chat with you so that we can make sure that everyone's aware of the answers that we provide as well. So
yes.
Thank you very much for having me, and thanks for attending, guys.
Thank you. Have a wonderful rest of your day, guys. Bye now.
Take care. Bye-bye.